All right, in this problem here, we have 2 points which are opposite corners of a square, and we have to find the other 2 points. And I got a couple different problems like that here, and we're going to do both of them. They're not too terribly difficult, but you have to keep some facts in mind, and you might want to write some of this stuff down. 1, a square is a type of parallelogram. A parallelogram has opposite sides that are parallel. Also in a parallelogram, opposite sides are always the same length. And in a parallelogram, the diagonals always bisect each other, which means the 2 lines that cut through the middle of the parallelogram cut each other in half. Okay? That's always. Now, overall, they might be different lengths. This one's longer than this one, but they cut each other in half. Next, a rhombus is a particular kind of parallelogram where all 4 sides are the same length. That's not true of all parallelograms, but special parallelogram called a rhombus, all 4 sides are the same length. And the diagonals of a rhombus, yes, they bisect each other just like a regular parallelogram, but they also perpendicular, right? So they meet at right angles. So special property of a rhombus there. Next, a rectangle has diagonals that are congruent. So a rectangle is, down here is a parallelogram that has all 4 angles are right angles. And just like any parallelogram, the diagonals cut each other in half, they bisect each other. They also happen to be overall the same length. Or that means that all 4 of these small parts, from center to corner, are all the same. And that's an important fact that we're going to use. Now, a square has all the properties of a rhombus because it's technically a kind of rhombus, it's a special rhombus, and has all the properties of a rectangle because it's a special kind of rectangle. So it has 4 right angles, it's a rectangle, all the properties of a rectangle, and it has 4 sides that are all the same length. So it has all the special properties of a rhombus, including its diagonals meet at right angles, just like the rhombus. They bisect each other, just like any parallelogram would, and they are the same overall length, or all 4 pieces from center to corner are the same length, just like a rectangle is. Okay? And those are the important facts we're going to use. So here, if we know that the diagonals of the square, right, and this we could draw one of them in, this will be one diagonal of the square, we know that they bisect each other, which means that the other diagonal crosses right in the middle. We know that they're perpendicular because it's a rhombus. If you look here, the slope of this diagonal is -2/1. -2/1. So the slope of the other one will be the negative reciprocal, which is +1/2. We're going the other direction, +1/2. And we know that it's the same length as the other one because it's a rectangle. So we know that the other diagonal is perpendicular to the first and is the same length. And that gives us our other 2 corners. Okay. This one over here is a little bit more difficult. Here we have our original diagonal. Right here, it kind of passes through this halfway point on the grid. So again, the second diagonal will have the same length, and its slope will be the negative reciprocal. And here this is down 1.5. Down 1.5. So to go the other direction, we have to go over 1.5 and up 1. Or back 1.5 and down 1. And there are our other diagonals. And this is like the coordinates 0.5, 1, 2, 2.5, over here 1, 2.5, -2.5, comma 0.5. Okay. So again, the important facts are that the diagonals of the square, they bisect each other because the square is a special kind of parallelogram. We used that fact. They meet at right angles because the square is a special kind of rhombus. We use that fact. And they're the same length as each other because the square is a special kind of rectangle. And so So all those properties are come into play when we're solving this problem. So actually how to solve the problem is sort of a secondary thing. The primary thing is to remember all these facts. Like I said, you probably want to take some notes on those. Parallelogram, diagonals bisect each other. Rhombus, diagonals are perpendicular. Rectangle has congruent diagonals. And square is both a rhombus and a rectangle and a parallelogram for that matter. And for your diagrams over here, just ordinary parallelogram with diagonals bisecting each other, a rhombus with diagonals having meeting at right angles. By the way, this is 5 units, and here up 3 over 4. We got that 3, 4, 5 triangle in there being used to make that rhombus. Down here is the rectangle, 4 right angles, that's what makes it a rectangle, and the diagonals are congruent, and also they happen to, from the center point, it's the same distance to any vertex. And finally the square, having all those properties, congruent diagonals, diagonals that bisect each other, and diagonals that meet at right